Hi there, Jim here. Today we're going to have a look at this multimeter from Neoteck. Neoteck is a company that sources products from a variety of manufacturers, and they brand them with their own particular brand. Neoteck tends to be, in my experience, fairly selective. They tend to have better offerings. They find sort of good products in order to source. So we'll have a look at this multimeter. And as with a lot of the multimeters that I go through, we'll be comparing it against this Fluke, but we'll get to that a little later. I wanted to just mention before we get started that if you found this video to be helpful, please give it a thumbs up, or better yet, subscribe to my channel. Questions and comments are always welcome. I appreciate the feedback as it helps me know where I can focus my efforts. And before I get started, I should mention that I received this item in order to perform an evaluation through the Amazon Vine program. Now, without further ado, let's get in the box. And then you can see that the box suffered a little bit in travel. I'm hoping that that does not have any negative impact on the meter itself. So, okay, so very much like the last multimeter that I reviewed, the item comes in a sort of a nylon pouch, and that's all that there is in the box. So the box is used to store a pouch. You wonder if they could get just as far if they could figure out how to brand the pouches. Now, let's see what's in here. The pouch is fairly simple. We've got here an instruction manual. Usually there are very few pages that are in English. Okay, so in this case we've got 14 pages for English, and German, French, Spanish, Italian, and Japanese in the same booklet. So a chunky booklet, but very little of it is devoted to English. It's fairly typical. We've got in here a nice pair of alligator clips, and so these usually will get attached to the end of the probes. We'll see how that works. So nothing too remarkable about that. So two of those, and in here there's a thermocouple. That seems to be the latest fad with multimeters these days. We have to measure temperature as well, so we'll have a look at that too. Of course, I'm not sure why, but there's a screwdriver in here. It's odd. I guess they don't have confidence that people who are buying multimeters will have screwdrivers. And then in the package, we've got a set of probes. Probes feel fairly nice. I can never tell the difference between PVC and silicone, but these are probably PVC. These particular probes, they don't have any sheath at the end, so a lot of multimeters, especially ones that are designed for use in higher voltage ratings or in high voltage areas, they'll have a little sheath cap that goes on the end in order to not expose such a large part of the probe for safety reasons. This is a set of probes from another multimeter that I reviewed a little while ago, and you can see the sheath at the end here that's used to sort of reduce the amount of metal that's exposed at the tip. So, like I said, that's from another model. So this particular multimeter does not have that. So not a big deal, but you can see that that's clearly not the audience that they're going after. And then in terms of these alligator clips, you've got to make sure to get the tip of the probe into the little socket here. Okay, and so then we have an alligator clip that we can use if we want to keep it stable and prevent it from moving around when we're measuring something. So the alligator clips are nice. I like that. And what else do we have here? We've got a pair of batteries. So it's nice that they include a set of batteries in the box. Although I have a huge supply of batteries, you never know. You might be missing a pair. And you know, it's got a nice plastic rubbery shell here, and the shell will peel off if that's your inclination. The shell has got a little groove at the edge here to kind of keep it in place. It feels nice. It's a nice little handheld unit. So it's not a big, chunky, huge unit. It's nice. It fits. I don't exactly have a large hand, so it fits into my hand fairly nicely. So that's what the unit is like. And I'm just going to pop some batteries in, and we'll see what it can do. It'll be away to the races, so to speak. So let's get the batteries in. Okay, and so a spot for 2 batteries there. And I want to sort of get a close-up there. I'm a little bit disappointed now because you'll notice that there is no collar there for the screw that's used to hold the battery door in place. And I thought it was a foregone conclusion these days that people were putting those brass collars there. So that's disappointing because that means that they're not really, I don't think things without a brass collar, the screw is just going to chew that plastic up over time after you place those batteries a few times. And so that's disappointing. I really do like to see a brass collar there. Anyways, it is what it is. Let's put the batteries in, and we'll just turn it on for a second to make sure. Yeah. Okay, it all works. Okay. Oops. Okay, can't seem to quite get that into the right spot. Yeah, that looks good. Still disappointed about that brass collar. Well, just need to make sure not to force the screw in. Okay, so there we got the meter, and we've got the probes. So we'll plug in the probes to get started. Most of the things that we're going to do are going to involve having the red probe there, and the black probe there. Okay, so there we are, and we'll turn this on. Fairly nice, and you can see there's a backlight there that we can turn on, and so it does double duty with the hold button. And there's also a flashlight feature here. So if we hold this button down long enough, the flashlight comes on. And once again, it's not super bright, but if it were a really darkened room, you would be able to see that it illuminates something. So it's let's say it's better than zero light, but it's not a very powerful light. But it is the sort of thing that a lot of the manufacturers of multimeters, especially in these sort of more consumer-oriented meters, I guess, or maybe the higher-end professional ones. I don't know. It's becoming a fairly common thing now, especially that LEDs are so commonplace. So a lot of the multimeters that I see these days, they're just throwing in an LED light there as an added extra feature that's not too hard to supply. So what I'm going to do now is I'm going to run through a set of tests, and I'm going to be pitting this Neoteck. It's branded here as VC837, And what's interesting is that the product sheet that I ordered from said it was an NTK244, so I'll have to look into that. It does look like the same product, but the branding tends to drift around because, like I say, they're using a product that is manufactured by another OEM, and the OEM has their own model number, and so perhaps this is the OEM model number. But in any case, we're going to pit it against this Fluke 117. So the Fluke 117, a fair bit more expensive. And I think most people have heard of Fluke. They're considered to be one of the gold standards, if not the gold standard, for multimeters. And so we're going to just see how it does. So let's start with DC voltage. Now, what I'm going to do is I'm going to set these up here a little bit so the screens are visible. And you'll be able to see me working down in this area here, I think. Let's see if we can zoom in a little bit. That's good. That's perfect. Okay. And so we'll take DC voltage. That's the setting there. So, of course, it's auto ranging, so it'll do everything on its own. We've got a battery in the bottom of the frame. We can see 1.53. 153, 153, 154. So pretty much the Fluke and the Neoteck here, they agree almost completely on the voltage. Now that was DC voltage. Let's have a look now at AC voltage. And so for AC voltage, what I tend to do is something that you tell your kids not to do. So I've got this supply cord, and it's live. Put the probes in. Let's pay attention to how long it takes to figure out the voltage when I put the second probe in. Not too bad, right? 121.4. 121.3. Okay, let's try that with the Fluke here. Put the unit into AC voltage. Put one probe in there, one probe in there, 120.8. Okay, and we'll do that again just to see the response time. 120.8, 120.8. Let's go back to the Neoteck for a second. .7. So you can see the voltage on the mains, it tends to vary by a few tenths of a volt over small periods of time. So they pretty much both agree on the AC voltage. So that's nice to see. And the Neoteck was fairly responsive. I like seeing that. Next thing that I want to look at is resistance. So I've got somewhere here a little test circuit. We'll be using this for a couple of things tonight. I've got things falling all over the place. And so I've got a resistor here. If you're good at your color codes here, that's a brown, green, brown. So that's 150 ohms. And so let's see what happens when we try that out here on the Neoteck. So we'll put the Neoteck into resistance mode. Okay. We'll test the two ends here. 150.2. 150.2. So fairly responsive. And it's interesting that the resistor is so close on. Okay, so now we'll try the Fluke. Same thing. 149.6. 149.6. So both fairly close in terms of the accuracy. I have sort of tested this before, and in general, this is a little bit under 150, so the 149.6 is more common. I've tested this with a few other meters. So the Neoteck is a touch high, but then resistors are never all that accurate anyways. So a pretty good showing there. Next thing I want to look at, let's just put this resistor back into the breadboard. We'll need that for later. Next thing I like to do is continuity. So continuity is on the same element here. And so that puts us into diode check. That's continuity with a little symbol there. And so my test for continuity is to see how long it takes for the buzzer to go off to tell you that there's that you basically found a connection. So that's pretty good. But you can see that sometimes when I'm tapping, really quick tap, it doesn't register. Whereas when we go to the Fluke, we'll put it into continuity mode, I can't, I've never been able to get the Fluke to miss. That's me missing. I've never been able to get the Fluke to miss. And so the Fluke is super sensitive, very fast. Just to go back here to the Neoteck, you can see that I'm doing the same sort of thing. So the Neoteck right, it makes, when there's a good solid contact, and if the contact is longer than a split second, you get this beep sounding, but it's not quite as fast as a Fluke, but still that's very good for the continuity. Now, some people might say, well, why does it matter? Like you're never going to be sitting around, banging your probes around like that to figure out whether or not you've got continuity or not, right? That's just a fake test. And the reason why I find that very important, you're often using continuity to try to find a short circuit, or to verify that some points are in contact. But if you're trying to find a short circuit, and let's say you've got a broken trace or a broken wire, that that continuity can be very intermittent, and it could just be something that happens for that split second, and then whatever is kind of going on in that circuit, it goes back. And so you want something that's going to pick up those really momentary contacts in order to help you when you're trying to troubleshoot. And so having that responsiveness on the continuity can be an important thing. Now, I mean, are you going to miss a lot of things with something that's a little touch slower like this Neoteck? Probably not, but that is why it's important to be able to have that extreme sensitivity on something like the continuity. All right, now the next thing we're going to look at is capacitance. So let's we're going to switch the Neoteck to capacitance, and I've got here a capacitor. It's rated at 47 microfarads. I can tell you from some previous tests that it's a little higher than that, but not much. It's about, we'll see what the meter says. So capacitors, electrolytic capacitors anyhow, are polarized, so we need to make sure to get the probes onto the right leads here. Okay, And so that's reading about 49.6 microfarads. And it takes a while. And it always takes a while for capacitance because it's necessary to kind of give a little bit of a charge into the capacitor. Now with the Fluke, diode check, capacitance, okay. Once again, we'll do the same sort of thing. Okay, 49.6. So we pretty much agree between the Fluke and the Neoteck on the capacitance, although you can see that the Fluke is quite a lot faster in terms of that measurement. We'll just go back to the Neoteck so you can compare. Okay, oops. Right, you can see it's taking quite a while. It eventually does come up with the expected value, but it just takes a while. And at first, you're not even sure that you've made contact with the leads on the capacitor. So capacitance readings, I say, are a little slow with the Neoteck. Accurate, but a little slow. Next item we want to do is diode check. And so diode check is a way to tell if the diodes in our circuit are working. They'll readout generally shows the forward bias voltage. And so switch that to diode check there. The symbol's showing. Now diodes are also polarized components. So we need to make sure to get the polarity right. The silver band at the end is the negative. So touch that and touch that, and let's pay attention to the display. Okay, so about 212, 213 millivolts, and pretty responsive. I'm happy with that performance. And if we'll do the same thing with the Fluke, put it into diode check. Okay, 195, 195, 196. So very close. I mean, we're maybe a difference of about 20 microvolts. Depending upon what you're doing, that level of significance might be important to you. So the Neoteck may be a little high on the bias voltage, but in terms of performance, it performs pretty well. The one thing you'll notice is if we orient this the other way, of course it's not going to show anything, right? We expect that to happen. I'm not sure if it's easy to pick up on the audio, but there's a little beep that comes out of the Fluke when it confirms that the diode is actually operating properly. So that's diode check. All right. And one more thing before we then go into the last measurement that I tend to do, and that last measurement is going to be DC amps. Non-contact voltage, I've got the Fluke and the Neoteck set up for non-contact voltage, and the sensors for these are at the top of the unit. And so I've positioned them down here in the frame a little bit. Now one of the things is I use this wire. Now let's pay some attention to this wire. So there's this is the ground side, and so the ground cord is over here, and then the hot wire is on this side of the receptacle or plug. And so when we pass this by, you can see it's kind of got to be right on the Neoteck, but it will, especially if we get right to the sensor, it will trigger. Whereas with the Fluke, okay, The Fluke is a fair bit more sensitive in its high mode. We can change it to low. And when the Fluke is in its low sensitivity, it's fairly similar to the Neoteck. Maybe a little more sensitive. So the low on the Fluke is about the equivalent of the Neoteck. Now, if we flip it around so that we've got the live part of the cord here closer, let's just do that. You can see now the Neoteck is reacting a little sooner. Let's do that from the side so you can get a sense of the distance. Okay, whereas the Fluke, very similar on low, but with the Fluke I have the option of the high sensitivity, and in that case the Fluke is able to sense the cord way out here, whereas out here for the Neoteck, nothing happening. So that's, if you're in an area and you're concerned, right, that sensitivity can be important because you could have a lot of wires going on and you'd like something maybe that would be sensitive. So certainly I think you can see when it comes to the non-contact, the Fluke, much more capable non-contact sensing than the Neoteck. Last thing that we're going to do here is we're going to try the temperature. So temperature is not something that this Fluke model has. This model is aimed more at electricians and electronics, although the current that it can sense is not very low. It only goes down to microamps, to milliamps, not down to microamps. This Neoteck has both an amp range, a milliamp range, and a microamp range. So more sensitive here in terms of the amps. We'll come back to amps in a second. But first let's look at the temperature. So we'll pull these probes out, switch that over to the sensor here. And so right now it's showing 26. I believe that that is off of an internal sensor. If we plug this in, okay, so now I've got the thermocouple plugged in and my fingers warming the unit up. So we can see that registering 34 Celsius, and if I press the select here, Fahrenheit, so 94 Fahrenheit, and that'll cool. And if I disconnect this, it should switch back to the internal sensor. So it's showing about 80. So it's a little high. It's not really 80 where I'm located. It's closer to 70, 72, or maybe 21, 22 degrees Celsius. But you can see that when the thermocouple is not plugged in, it's based on an internal sensor, and when you plug it in, it switches over to the thermocouple. And so the thermocouple, it generates a small little voltage that is sensed by the circuitry in the multimeter, and that's converted to a temperature reading based on the voltage that was generated. Okay, so that works reasonably well. Might not be extremely accurate, but on the other hand, for the kinds of things that you're generally trying to measure, you're trying to see if there's a fairly coarse level of temperature change. So you're not going to use this to check on the weather or anything like that. So in terms of temperature reading, the Neoteck is about the same level of accuracy as pretty much every other multimeter that I've used that has one of these thermocouples. They seem to be calibrated in that little range, and they're about 3 or 4 degrees Celsius high in my experience. The last test that I'm going to do is of DC amps. And in order to test DC amps, I've got a little breadboard with a circuit here. There's a breadboard power supply. The breadboard power supply is going to put 5 volts onto this rail. I've got the resistor that I was using before, so it's a 150 ohm resistor. And if we do the math according to Ohm's law, the voltage, 5 volts divided by the resistance, 150 ohms, is what we would expect the current to be. So 5 divided by 150 is approximately, or is 0.033 amps, or 33 milliamps, depending on how you look at it. So we're going to use this circuit to test that. And the other thing to note about amps, when doing amps, unlike many of the other measurements that we do, when we measure amps, we insert the meter in series with the circuit in order to measure the current flowing through the circuit. And so that's fairly different from a lot of the other measurements we do. When we're measuring resistors, capacitors, diodes, we're pulling those components out of the circuit in order to test them. The only other thing that we tend to measure live in a circuit is voltage. So we measure a live circuit with voltage between a test point and the ground point, typically in the circuit. But we don't disconnect anything in the circuit, whereas when it comes to amps, we need to insert the meter directly into the circuit. And so the circuit that you can see, there isn't really a closed circuit from this resistor back to the negative here. So there's no current flowing until I put my probes in there to do the test. Okay, this one isn't really doing anything right now, but this one I'm going to use to get back to the negative point, the ground point. And so that's a difference to keep in mind when measuring amps. When you're measuring amps, you're going to be measuring with the meter in series with the circuit. So I've got this. It's got a 12 volt supply coming in. I'll turn that on so you can see the LED is on there. And we'll just lay this down. We can see everything on the screen. Okay, so the screens are visible. Now, one of the things to keep in mind is often when you're measuring amps, the probes need to be reconfigured. Now, for the Neoteck, we can see this comment isn't going to change. The red probe here, we can see milliamps is here on this side, whereas often, and on the Fluke, we actually have to shift this over for amps. So we have to move this red probe over for amp measurement on this side. So something to be careful about, because only when we get into sort of a higher amp range do we move the probe here over onto this side. So for the milliamp reading, we keep the probe here. So now we've got our probes, and so we're going to take the Neoteck, I'm going to put that there, there, and we see 32.3, 34, 32.3 milliamps. So pretty much exactly, or almost exactly what I expect, and pretty quick in terms of picking up the milliamps. With the Fluke, I've got it in, the range is in amps, not milliamps. We'll do the same thing. You can see, and it's dead on for what I calculated, which is 0.033 amps. The Fluke does not have a milliamp range. So pretty much in agreement, the Neoteck might be a teeny bit low. Maybe if we were rounding, we would say that 32.5 there, so that would round to 33, so that would match what we're seeing on the Fluke. So fairly good accuracy there on the Neoteck when it comes to measuring milliamps, and we can put the Neoteck here into the amp range. And of course, in the amp range, you can see it's not quite measuring right, and of course that's expected because this is where the probe should be for milliamps. And so if I've got it in the amp range, and this is a little awkward then, I've got to take the probe here, and I've got to shift the probe over here. Okay, and now, same thing. and now it's reading the same way the Fluke does, 0.032, so maybe one milliamp difference in the measurement. So a very small difference in the measurement between the Neoteck and the Fluke. So fairly good accuracy, I would say, except a little bit awkward in terms of having to move the probe over depending upon which range you're using. And one of the things that we would have to check the manual on is which section we place, or which place we put the probe for microamps. Okay, so that's a little bit of a puzzle, but I think we would probably figure that out fairly quickly. And that's all we've got. And so overall, I think a fairly nice multimeter here in the Neoteck. All of the measurements have been reasonably accurate. I'm pretty happy with the operation of the Neoteck. The two things that could be better in the Neoteck, the battery on the back that I mentioned, the battery case. And the other thing that I'd like to see on the Neoteck that would be better would be the performance on the capacitance test. So the capacitance test, if you recall, was fairly sluggish compared to the Fluke, but all of the other measurements were pretty good. The non-contact voltage sensitivity could also be a little better, but not really terrible. It is a challenge with these sensors and with the exact placement of the wires in the wiring. So maybe not fantastic performance on the non-contact voltage, but somewhat reasonable. Although if I were working with AC voltage or AC circuits a lot, I would be much happier to use to the Fluke with its greater sensitivity. And that's all there is. So thanks for watching. If you enjoyed this video, please subscribe to my channel. And until next time.